Alright, so for the sake of time, we're going to kind of run through the rest of this rotations and dilations together. So here we have the center of rotation and the angle of rotation, just two definitions. Center of rotation is where the point that you're rotating around. The angle of rotation is how much you are actually rotating around that center. So this one here wants us to draw it 45 degrees counterclockwise, would mean that we're going this direction. And so basically what we want to do, really you would want to use a protractor for this. Don't have a protractor on this tool, unfortunately, but it looks like that's about 45 degrees, and you want to make sure that you are drawing your lines the same length. So that's probably about where R is going to be. Again, this is going to be fully on estimation because I don't have a protractor or a ruler, for that matter. But that's what you would want to do, is have those two things to make sure that you're drawing the same distance away. So I'm actually going to do these in different colors here. But not that color, hold on. What happened there? That was weird. Just so I kind of have some visual judging on how to do this without so that is where I'm going to place V. Just a guess here. I don't know if I'm going to like how this is going to look. We'll see. It's not looking too terrible so far. Oh, it's something like that. Pretty close to it anyway. 45 degrees. And again, the angles are purely estimation, so I'm sure some things are off, but that's okay. You get the idea. You measure the distance away the point is, and then from that line you make an angle. It's not too bad. So rotations on the coordinate plane are a little bit more complicated unless these three things are happening. If they are counterclockwise about the origin, these three things can happen depending on the angle, 90 degrees. Then you just flip them, change the sign of the Y, or change the sign of the Y flip, and then the rotation around the counterclockwise, around the origin counterclockwise 180, you change the sign of both X and Y. If it's 270, then you change the sign of X and flip them. So again, 90, change the sign of Y and flip. Rotation, or 180, change the sign of both. 270, change the sign of X and flip. So this one here, you're rotating 90. So that means we need to go, oops, X, Y is going to become negative Y, X. Just to double check that, so you know what I'm looking at. Oops, come on, there we go. So that top one is what we're looking for, negative Y, X. So we need to come up with our points on our graph here. So R is at 2, 1. So that means R prime is going to be at negative 1, 2. S was at 4, 1. S prime is going to be at negative 1, 4. T was at 5, 3. T prime is going to be at negative 3, 5. J is at 4, 4. So J prime is at negative 4, 4. G is at 1, 4. So G prime is at negative 4, 1. And D was at 0, 3. D prime is going to be at negative 3, 0. So I do see a bit of a problem. Our graph is not going to be very complete because our table or our graph itself is not very complete. I'm going to try to do this by hand as easily as I can. I kind of bleed into the numbers here, unfortunately. So R prime is at negative 1, 2. S prime is at negative 1, 4. T prime is at negative 3, 5. J prime is at negative 4, 4. Sorry about the motorcycle driving by. G prime at negative 4, 1. And then D prime at negative 3, 0. Now we're ready to go ahead and connect our points. Not with a dotted line though. Kind of hard to see the purple on the black there, but it's there. And there's our weird looking hexagon, rotated 90 degrees about the origin. A dilation, though, is basically where you make something either larger or smaller, multiplying the coordinates by whatever it is. So if you're looking to make it bigger, a whole number, smaller, a fraction. So we want to copy this trapezoid and increase it by a scale factor of 3. So what that means is I'm going to go back to my dotted line here. So from C to Q, I need to extend it out to here. From C to P. Again, I have a bit of an advantage because this thing will do this for me. For the most part. C to S. It's not perfect, but it'll be all right. And finally, C to R. And again, we connect our points. And there's our enlarged trapezoid. P prime, S prime, R prime, Q prime. Increased by a factor of 3. So what I did was I measured the distance from C to Q, and I just copied that line 2 more times. So it's a distance of 3 away from C instead of just a distance of 1 unit or whatever that length is. So this one here is a way that some puppeteers use to do this. We're going to basically make a proportion. So what we're looking for here is let's draw everything out and see what we got. So from L to I, the L is our light source. So from the puppet to the light source is 24. You want to know what this distance is from puppet to projection. If we want the 9-inch puppet, so from I to M is 9 inches. To make a shadow from I prime to M prime, that is 49.5. So really what that means is we kind of have 2 triangles here that we're looking at proportion-wise. So that means that we want the distance from light source to puppet over the distance between I prime to M prime. So let me write this out. We want L to P prime over I prime M prime to be equal to L to P over IM. Now, LP prime is equal to LP plus P prime. And we know what LP is. That's the 24. We know what everything else is. So we're going to replace that in our proportion. LP prime, again, is that 24 plus PP prime, the one we're looking for, over I prime M prime, which is 49.5, equal to LP, we already said, is 24, and IM is 9. So what we want to do with proportions is we cross multiply. So it's going to be 9 times 24 plus P prime equal to 24 times 49.5. 9 times 24 is 216 plus P prime times 9. I forgot the 9. Can't forget that. Got to distribute to both. And 24 times 49.5 is 1188. So first thing we want to do is subtract 216 from 1188. Which is 972. And then we're going to divide both sides by 9. So the distance from puppet to the shadow is going to be 108 inches. We got one left. So dilations in the coordinate plane, all they do is you just multiply the coordinates by whatever k is, your constant or scale factor. So here we have this trapezoid. We want to dilate it. Now, Typically, when you think of dilating, you make things bigger, but sometimes you make them smaller. So we're going to dilate it by a factor of 1/4. So all that means is we're going to multiply it by 1/4. So E at -8/4 becomes E prime 1/4 of 8, or -8, is -2, and 1/4 of 4 is 1. And then we have F at -4/8. And thankfully, all these numbers are the same. It's just depending on the negative. So F prime is at -1, 2. G is at 8, 4. H is at -4, -8. So G prime is going to be at 2, 1. And H prime is going to be at -1, -2. Now we're ready to go. So negative, got to be careful too because this graph is scaled. So got to be wary of that. So -2, 1 is actually just right here. -1, 2 is right there. 2, 1 is there. And -1, -2 is right there. Kind of looks a little wonky, but oh, I went the wrong way, that's why. -1, -2. There we go, that looks better. And there it is. Let me label our points. F prime, E prime, G prime, and H prime. And that's how you do that. It's pretty simple. Just multiply by whatever the scale factor is. So again, I'll write that out. -8 times 1/4 is -2. 8 times 1/4 is 2. 4 times 1/4 is 1. -4 times 1/4 is -1. So the last thing here is just for your exit date. See you next week.